Okay, I'm very angry right now because I just did this whole video explaining this and it just completely deleted itself. So, I'm going to try to quickly explain what I talked about. So in this video, I'm just going to tell you about expanding on Taylor series. We're going to do another example to make sure you understand how to do it. And then I'm going to teach you how to find the interval convergence of a Taylor series. So here I'm using f of x equals natural log of x. It's centered around x equals 1, and the reason is because you can't plug in 0 because natural log of 0 does not exist. There's a vertical asymptote there. So you have to start at x equals 1, which means that our eventual series is going to start at 1. So what I did here was I didn't do f, but f equals natural log of x. And then I took the derivatives of all of those. You get 1 over x, negative 1 over x squared, 2 over x cubed, negative 6 over x to the 4th, and 24 over x to the 5th. Then I plugged in 1 for each of these. For f you get 0. For f prime you get 1, negative 1, 2, negative 6, and 24. Then I plug these in. Remember that because the first one's 0, there is going to be no 0, 1, where it's x minus 1 to the 0. So we're skipping that 1 and just doing x minus 1 to the 1, minus x minus 1 squared over 2 factorial plus 2. X minus 1 cubed over 3 factorial minus 6 x minus 1 to the 4th over 4 factorial. Now you might be thinking, oh, I don't really see a pattern here. Well, the reason that if you simplify it, you will. 2 factorial, same thing as 2. 3 factorial is the same thing as 3 times 2 times 1, which is 6. 2 over 6 is the same thing as 1/3. 4 factorial is the same thing as 24 because it's 4 times 3 times 2 times 1. 6 over 24 is the same thing as 1/4. And now I'm guessing that you see a pattern. You see that it's alternating negative, positive, and the denominator is going 1, 2, 3, 4. And for that reason, you're going to get negative 1 to the n plus 1 times x minus 1 because it's centered at x equals 1 to the n over n. Hope you saw how I did that because I did a really quick summary. I just kind of explained this twice, so I thought I would just kind of explain this quickly. Once again, we're going from 1 to infinity. That's why this is n plus 1, because you want to start positive, and if you just made this n, then it would start negative, so you have to n plus 1. Now that you know this, it's time to talk about the interval of convergence. So, I'm going to rewrite this at the top. And the interval of convergence, we're going to have to use the ratio test that we learned last unit. Now, I already kind of talked about how you could do this, except I never did an example with it, so like I kind of said it at the end of, I believe, the last video from the last unit when I was talking about the ratio test. So I thought I might as well do an example now. This is what natural log of x is. We can just say natural log of x equals this because this is natural log of x. The infinite series of this equals natural log of x. So we're going to do the ratio test, which if you guys remember, you do the limit as n approaches infinity of this, but to the n plus 1 divided by this, basically, to the n. So it'd be negative 1 to the n plus 2 because it's the n plus 1 plus 1, so it'd be n plus 2 over x minus 1 to the n plus 1 all over n plus 1. And then we're going to multiply this by the reciprocal because the same thing as dividing. And by the reciprocal, it's going to be reciprocal of this because we want the original one. This is a review of the ratio test. So it'd be negative 1 to the n plus 1 times x minus 1 to the n. Now it's time to simplify this. So this right here, x minus 1 to n plus 1, is the same thing as saying x minus 1 times x minus 1 to the n plus 1. That's just an algebra rule. Or I'm sorry, to the n, that's just an algebra rule, so we can cross these out and simplify that. Same thing here, this is the same thing as saying negative 1 times negative 1 to the n, so we can cross that out. Or n plus 1, I'm sorry. Cross that out. And you're left with an n plus 1, and an x minus 1. So, there's also a negative 1 over here, but because we're taking the absolute value, it's not going to matter. So, as you can see, n over n plus 1, that's just going to go to 1, but it's going to be to the coefficient of x minus 1. So that means this equals x minus 1. So as we talked about last unit, then you're going to put that in between 1 and negative 1, and you're going to solve for the interval of convergence, which is 0 is less than x, which is less than 2. However, the catch is, whenever you use the ratio test, I think I said this very quickly at the end of the ratio test video, but I'm just going to reiterate this. that whenever you choose the ratio test to check for an interval of convergence, you always have to check the bounds. You need to check to see, is this going to be less than x or less than or equal to x? So to do that, you're going to have to plug those numbers in, and a lot of the times they'll kind of work out nicely, I guess. This is supposed to be x. So let's do it. I'm just going to write these both out. Just give me 1 second. This is a very squeaky pen. So as you see, for the x's, I just plugged in 0 and I plugged in 2. This is the 2 one, this is the 0 one. And I did that because I just want to check to see if at the bounds, does it converge? And if it does, then that would be or equal to, because we want this to converge. This is the interval of convergence. So, this one, you're going to get a negative 1 to the n plus 1 times a negative 1 to the n, which means that no matter what, it's always going to be negative on the top. Because if you think about it, I'm trying to see how to explain this. If you think about it, if you put in a 1, then this would be squared, but you'd be multiplying times negative 1. You put in a 2, then this would be squared, but this would be to the third. So that means this is always going to be negative 1, basically. And let me just see how I'm supposed to exactly reiterate that. Okay, so because of that, I'm sorry, I don't know why I had to walk away to explain this. Then you can pull out the negative 1, and you get n equals 1 to infinity of 1 over n, and that is the harmonic series, which we know diverges. So diverges, harmonic, and that means that this is not or equal to, because at 0 it diverges, does not converge. Now what about here? You're going to get a 1 to the n, which is just the same thing as 1, because 1 to the n will always be 1, so you're going to end up with this, negative 1 to the n plus 1 over n. Now we're going to do the alternating series test. So 1, we're going to check the limit of the absolute value, which would be the limit of, as n approaches infinity, of 1 over n, which is going to be 0. Check. And now 2, we're going to take the derivative of the function, so it's going to be f of x equals 1 over x, and we're going to take the derivative and get negative 1 over x squared. No matter what value of x you put in, it's always going to be negative, which means that it's decreasing. So check, therefore, this converges by alternating series test. And for that reason, that's going to be or equal to. That right there is the interval of convergence for natural log of x.